You cannot know what is the horizontal component and what is the vertical component. You can only know the angle. You know what I mean or not? When you throw something up, as when you throw, you can only measure the angle, okay, and also the velocity that when it leaves your hand. No, you cannot just throw the ball there. Oh, now I know the vertical component is 8, the horizontal component is 6. You don't know, right? You only know the angle. So in that case, you have to use the angle. The angle. The horizontal component is V cos of this angle here. This angle. Let me see. Yeah. This angle. The cos of this angle, the angle with the horizontal, right? So the horizontal component is V cos theta, or we call it theta naught, the initial angle. Then the vertical component, this is the horizontal component. The vertical component is V sine theta. Okay, it's V sine theta. I didn't type out. Oh, alamak. The horizontal component is V sine theta. Okay, so sometimes you may need to use the equation in this form. Okay, V cos theta, the horizontal component is V cos theta, the vertical component is V sine theta, right? And the horizontal component is not subjected to gravitational pull. The vertical component is subjected to the gravitational pull. So you have to minus gt, right? The final velocity is V naught sine theta minus gt. And the displacement, the vertical displacement is V naught sine theta t minus half gt squared. Okay, so if it is not given the vertical and horizontal component, you have to resolve it using sine theta and cos theta. Okay, so far any question? No, no. No, then you read this problem 3.1, example 3.1.
Neglect example 3.1. A ball is thrown so that its initial vertical and horizontal components of velocities are 40 meters per second and 20 meters per second respectively. Use the motion diagram to estimate the ball's total time of flight and the distance it travels. I think you spelled it wrong.
I think the spelling here is wrong.
Travels
Transverse.
before hitting the ground. Transverse or travels?
Transverse. Never mind. This spelling. Transversely. I have not seen this spelling is wrong. Okay. A motion diagram, right? Calculate the total time of flight, the distance before hitting the ground. It means like this, huh? Okay. When you project the ball, huh? When you project the ball, it moves in a parabola shape, right? It moves in a parabola shape and comes down. Now, at this maximum height here, at this maximum height, there is no vertical component of the velocity, because the vertical component at the maximum height is instantaneously zero, right? So there's no vertical component, only the horizontal component. So this defines the maximum height. And if you draw a line, right? If you draw a line like this, right? So the path taken by the ball, they it is actually symmetrical about this center line, the red line that I have drawn. Both the path and the velocity, they are symmetrical about this line. And this line is drawn from the maximum height. Now, what does this mean? What I mean by the position and the velocity is symmetrical about this line. It means like this. Now, let's say uh, this at this point here, how to mark this point? Let's say I mark this point here, okay? Now, at this point here, the distance from the center, from the maximum point, the horizontal distance, let's say it is 5 meters. Then on the downward journey at the same level, you will also be 5 meters away from the center here. Okay, right. Uh, let's say at this position here, it is at a certain distance from the center line, the symmetrical line here. Let's say it's 10 meters. Then on the downward journey, at the same horizontal level, it will also be 10 meters away. So the flight is actually symmetrical about the line going through the maximum height. Okay, not only the distance is symmetrical, the velocity, the speed is also symmetrical. Let's say at this position here, the vertical component is 8 meters, and here horizontal component 6 meters. Now, at the same level, that means at this position, the horizontal component is 6 meter per second. The vertical component is also 8 meter per second. Only thing is the 8 meter per second here is pointing upwards. The 8 meter per second here is pointing downwards. That is the only difference, right? So in terms of distance, they are symmetrical about the center line. Not only that, in terms of velocity, not velocity, not so, we say the speed. In terms of speed, they are also symmetrical. Okay, right. So that is one thing you need to know, right? Then if they talk about the time of flight means the time in the air. That means it is the time when it is lifted up until it falls back to the ground. So the time taken for the whole journey here, from this level, the horizontal level, then back to the ground, from the ground level up, then back to ground level, the time taken is called the time of flight. It is called the time of flight. Okay, so the time taken for it to travel from here back to the ground is called the time of flight. And they ask, what is this distance here? What is this distance here? Now, the term that we use is actually, we call it the range. Range. And how to that distance is called the range. range. We call it the range. Right? This distance from the starting point here until the place where it lands. So this is the range. And this is the distance that we want to find. Okay, so now coming back to the problem, right? The ball is thrown vertically 40 and horizontally 20, right? We are given the component instead of the angle of projection. Okay, so never mind, we just accept it. Acceleration is negative g. Now in this problem they use negative 10 meter per second, right? Because they ask us to estimate. I think the word is estimate. Yeah, they ask us to estimate, and they ask us to use negative 10 meter per second. Okay, then the acceleration is negative 10 meter per second. The initial velocity, the horizontal one, is 20 meter per second. The initial velocity, the vertical component, is 40 meter per second. Right. Okay. Now using the symmetrical properties of the flight, if the vertical component here is 40, the vertical component here is negative 40. Is negative 40, right? So you move up and come down here. We are talking about the vertical component. So we use the formula for the vertical component, Vy equals to V naught y minus gt. So at the end here, when it has landed, or when it's about to land, so the velocity is negative 40. The initial velocity is 40, and the acceleration due to gravity in this problem they use negative 10. So you move the 40 over to the other side, then it becomes 80. So 80 divided by 10 is 8 seconds. So we know the time of flight is 8 seconds. So the time of flight is 8 seconds. So we are going to use this time to calculate the range, how far it has traveled horizontally from the starting point to the point where it lands. So what is that distance? So we use the time here, excuse me, we use the time that we have found earlier, 8 seconds. So this distance, which is called the range, is actually the horizontal distance. So we use the horizontal component, which is constant throughout the journey, multiplied by the time. Horizontal component is 20. That means it's moving in front at 20 meter per second. The time is 8 seconds. So you multiply 20 multiplied by 8. So it is 160 meters. And we say that the range from here until here is 160 meters. So when you calculate the range, you only use the horizontal component, right? But the time, you get it from the vertical component. Any question? Okay or not?